everyone. So it's not morning. Good afternoon, everyone. So today we are going to have the session that is on one-way ANOVA and repeated measure ANOVA. That is the difference in mean or median between two or more than two groups. That means more than two groups. So could you attempt those activity or the assignment at home during the weekends? Because you have to submit all those assignments. Final one, you have to convert all the assignment, the write-up into a PDF form and then submit it at the end of the session. Maybe 2 days, you may take 2 or 3 days. It is not necessary that tomorrow the session is getting over, so tomorrow itself you have to submit. No, you may take 2 or 3 days and then you may submit it. Okay, so I'll start sharing my screen. So is my screen visible to all of you? Is the
Yes, madam.
Okay, and am I clearly audible?
Yes, madam.
Okay, thank you. So like all other sessions, this session also we will first cover the basic concepts. Then we'll go to the research questions. Okay, let me check my volume once again. So is it better or the same? Okay, Manoj is also saying the volume is
Now better, now better.
okay, okay. Thank you. So I'll be telling the basic concepts first. Then we'll see what are the research questions for which we need this one-way ANOVA. Then the underlying assumptions and hypothesis for this one-way ANOVA. What are the commands and how to write interpretation. And then at the end, I will summarize once again the commands. So one-way ANOVA, which is also known as the analysis of variance. You have known now by this time that what this variance is. So we always talk of something like sum of squares. And when you divide that sum of square by the sample size minus 1, that is known as the variance. And under root of that variance is the standard deviation. So in a way, square of standard deviation is the variance. So this one-way analysis of variance, which is also known as the between subject ANOVA. The other name of this one-way analysis of variance is the between subject ANOVA. It is also known as the one factor ANOVA because there is a two-way ANOVA also. And we are not covering those other types of ANOVA in this session because this is a basic GEMOV. Maybe in the advanced course, we may go with the two-way and the other type of interactions which are there with the two-way and three-way ANOVA. And in this, you have to compare the means of more than two groups. Since there are more than two groups, you do a post hoc analysis. That we'll see between group comparison. How do we do it? So there is something known as, like if you start asking these questions, that what is the difference in average BMI between the three races, amongst three races, and the categories of those races are white, black, and others. So there are three categorical variables in this case, and you are seeing the difference in the average BMI. Similarly, the second research question could be, is there any difference in the post-operative pain score across surgical technique 1, surgical technique 2, and surgical technique 3? So there are more than 2 categories, and the categories are the surgical technique 1, 2, and 3, and you are going to see a continuous variable, which is a pain score. So then you can apply this ANOVA. Or does the student satisfaction level varies across various teaching methods? And the various teaching methods are lecture, demonstration, and case-based learning. So there are more than 2 categories, and here there are 3 categories. And the continuous variable in this case is the student satisfaction level. So in all these 3 research questions, what have you seen? That there is a continuous variable, and we are measuring the mean value of this variable across more than 2 categories. That means 3 or more than 3 categories. So the appropriate statistical test for such type of research question is one-way ANOVA. Now, what are the research design which is possible in case of one-way ANOVA? So like independent sample t-test, if you can recall the research design of independent sample t-test, the similar research design is here, except that in independent sample t-test, we study about 2 groups, whereas in ANOVA, there are 3 or more than 3 groups. So if you want to know the mean difference between the 3 independent groups, in this case, you can see the 3 categories are the male, female, and transgender. So there are 3 categories, and you are measuring the mean cholesterol level in these 3 categories. Then you can apply one-way ANOVA. The second type of research design, which is possible for this one-way ANOVA, is you want to see the mean difference between the 3 interventions. That means the similar exercise which we did in the independent sample t-test, that there are 3 groups here. So there is a dietary group, there's an exercise group, and there's a control group. So we are measuring the blood cholesterol level after 6 weeks of exercise training program in the intervention 1, and intervention 1 was diet, intervention 2 was exercise, and the third was the control arm. So there are 3 different arms, and you want to measure the post-intervention blood cholesterol level. So if you want to see the difference in the mean level of these values between diet, exercise, and control, then you can apply one-way ANOVA. The third research design could be, so can you tell me what can be the third research design? Please type in the chat box. Let me see the chat. Pre and post. True. Vikram, yes, 3 surgery that is there, but we are seeing that you can have a mean difference. You can have a after the end of the intervention, and then Anju is right. Anju is writing pre and post. So true, if you have got 3 groups, but you are having a pre-intervention score and a post-intervention score. And if you want to measure the change, so if you want to measure change also, that is the difference between pre and post, then also you can apply. So mean differences in the change score. So here, the first group is the diet group. So this is, you can see that we have got a pre-cholesterol level of the, like a pre-intervention level, that is the pre-cholesterol. And then we have got the post-intervention, that is the post-cholesterol. And this difference, we have got the difference in the pre and post. If you want to measure the mean difference in these three groups. The first group is the diet, the second group is the exercise, and the third group is the control. Then we can go for this ANOVA. So what are the underlying assumptions? So the first is that dependent variable should be a continuous variable. So we have seen in all these three cases, like BMI score, VAS score, and the third one was your satisfaction. So all these three were measured on a continuous scale. The second will be your independent variable should have a more than two categories. And all these three cases you have seen that the variable was having more than two categories. The third is your independence of observation. Categories independent of each other. And that we have seen that if you have counted one variable in this thing, then you cannot count that individual in any other category. So another assumption is the dependent variable, it should be normally distributed. Again, the same which we did in the independent sample t-test, that it should be approximately normally distributed. Because this ANOVA is also a very robust test. And if you don't want to express your result in median or mean rank, then you can take a call to apply ANOVA even if it is not very strictly normally distributed. And there should not be significant outliers in the dependent variable, and there should be homogeneity of variances. So we talked about the homogeneity of variance in the independent sample t-test. And what we talked, that the sample which you are drawing from the population, all the population should have the same variance. If that assumption is not met, then you will take the Welsh ANOVA, like we used to take the Welsh t-test. Similar concept is there. If the homogeneity of variance concept is not met, and the same, if you can recall, that we test by the Levine's test of homogeneity of variance. So equal variance is assumed, then the p-value will be more than 0.05, and then you have to take the classical ANOVA. If the variance is not met, then you will take the Welsh ANOVA. So the null hypothesis is there is no difference in population mean of the three groups. That means all are equal. And the alternate hypothesis is that there is a difference between the mean difference of the three groups. So now we will elaborate a little bit more on the variance concept, because on day one, we told that we will talk of variance more in ANOVA. So in ANOVA, you have got two things. There are three groups, and then you have got individual which are there in one group. Like, let's say, if there are three groups, normal BMI, overweight, and obese. So you have got a group of normal BMI people, a group of, let's say, overweight, and a group of obese. So there will be difference or the variance within a group. And then there will be difference between the group. So we talk of two types of variances: within group variances and between group variances. So again, recall from the previous example what a variance is. So suppose this we are elaborating on the within group variance. So let's say this is a black race. You have got 500 individual and you have got those 500 values of BMI. So you have calculated, you have seen like how many of there from the 18 BMI. So this is the frequency, and you have plotted a graph between the frequency and BMI value. So you can see that this is the graph. The graph looks like this. So this is a subjective way of measuring variance. So the broader the graph, in this case, you can see if the graph is very broad. So you can see this is the area. If it is very broad, we can say that the variance is more. If it is narrow, then we say that the variance is less. So this is subjective way of assessment of variance. Now, and this is known as the within group variance, because there is a only single group, that is the all black people. Similarly, you can have a group variance of the other race, that is white. So in this case, you can see that this is a white population, and you have got the similar frequency distribution of these BMI, and this is the variance. This is the variance of all the white individual. This is the variance between the others. The third group is the others. So you have the variances of all these three groups. So these variances are known as the within group variances. Now, so if by this picture, can you say, this is a hypothetical situation again of 500% from each race, and this is the normal distribution curve plotted for each group. So can you subjectively say that which race has got a high variance or the highest variance? Please type in the chat box. Others. Okay, all correct, all correct. Yes, so seeing the spread, you can say that it is the others which has got the highest variance. So now this is a subjective way, like we did. And everywhere in the statistics, there are two ways to judge or to assess that. One is the objective and the one is a subjective. Like in normality also we say that QQ plot is a subjective way and Shapiro-Wilk is a objective way of assessment of normality. But if I want to measure it's in the numerical value, how will I do it? So it can be calculated and the software gives you that value. So first we will calculate the mean values for each group. So like for black, it is 20, white 22, and others 24. So we are just telling you these concepts because whenever you see the result, you should be able to remember what is happening in the background. Otherwise, you don't need to calculate it. The software does it for you. So now within each group, what I will do, I will subtract the individual value from the group mean value. I will get a difference and then I'll square it, which is known as the square of that. And then, so this is suppose for 5 individual we are showing you. This is a group mean and I have deducted this from 14 from 20, 13 from 20, 23 from 20. So that's why it is -3. But positive or negative sign does not matter here because ultimately we are going to square it. So then it will become positive. So this difference value, this simply tells us how far the individual value is from her group mean value. That's the point of idea which we want to convey, that it tells you the difference from the distance from the overall mean. So what we do, we do a square of it and then we total it, which is known as the sum of square. And then in the denominator, we divide it by the number of individual minus 1. So this is regarding the variance. So this variance is an objective way. So we have got something 36.5, which is the variance of this group. So this sum of square value, divided by n minus 1. This is the variance for BMI for this sample. Similarly, you can calculate the variance for black and for white and for others. So you can calculate them objectively. So if the individual values in a group are far away from the group mean value, then the group variance will be high. And if it is very near to the group mean value, then the variance will be low. Similarly, we can calculate the group variance by subtracting group means from the overall mean, and then we can square it, and then that sum of square divided by m minus 1. So here it is the between group variance. So what is between group variance? We have got the group mean of these three groups. And if you take a mean and then distance from that group mean, overall mean, and then square it, like there are three groups, black, white, and others. So initially what I taught, that was a within group variance. Now there is something known as the between group variance. So how many groups are there in this case? Please write. How many groups are there in this case? 3. Kavita, Deep, Vikram, Devidarshi. So thank you, Priyanka, Taizeen. So you can see that there are 3 groups here. So now what is the difference of the variance, or what is the group variance? So in that case, you will take one group BMI, the other group BMI, and the third group BMI. Again, you will calculate a overall mean. So overall mean of, like individual mean of this group black is 20, white is 22, others is 24. And this overall mean, if you take a mean of these 3 values, it will be 23. So what you do, that you like deduct these values and then you square it. So this 5.5 will be your between group variance. So we have talked about 2 concepts, within group variance and the between group variance. Now what is a F statistics? So similarly, if group mean values, if they are far away from the overall mean value, then your between group variance will be very high. If it is very near to the overall mean, then it will be very low, or vice versa. So what is F statistics? F value or F statistics is the ratio between the between group variance and within group variance. And under null hypothesis, the value of this is 1. So you may get 4 typical situations in a study. There can be first situation where your between group variance is high and your within group variance is also high. So if you focus on this graph, you can see that this distance is very wide. So between group variance is high. And this distance is also wide, especially the first and third, even these 2. So your between group variance is also high. In this case, you can see that these curves are narrow. So between group variance is high, but within group variance is low. Then comes a curve like this, whether it is where it is overlapping. So if there is an overlap between the curve, we say that between group variance is low, but see the spread of each curve. Then we say that within group variance is high. And then something, a curve like this, when the individual curve is also narrow and they are crossing each other, then we say that there is a low between and low within group variance. So am I making sense to all of you? Are you getting whatever we are talking, or do you want anything to be retold or to be again said? So okay, Rupali, Hriday, 2 people said yes. What about others? Deep, Shirley is asking for a repeat. Okay. Manoj, Vikram, yes. Okay. So I will again repeat. So Shirley, from where should I repeat? Can you guide me? Previous slide. Okay. So previous slide means this one. Do you want to tell me between group variance, Shirley? Okay. Yes, this, Priyanka. Okay. Shirley graph. Okay, I'll start from this point. So all of you can do this exercise on your this thing, phone also. You can calculate it. See, we have done like how to calculate variance. So remember, there are two types of variance. There is a within group variance. Like, let's say, for example, in this, maybe in this session, okay, there may be many groups, but I have formed 3 groups depending on 3 branches. Maybe community medicine, the other than the community medicine, and then third, maybe the surgery. So community medicine, surgery, and other. So there are 3 groups. Now, there will be 2 type of variances. One will be from and if say like continuous scale, which I am talking of is, let's say IQ, mean IQ. Maybe I have got some tool by which I will measure the IQ. So there will be the variances in the IQ between each group. Like there will be variance of IQ in the community medicine group student and the surgery student and then the others. Okay, this is the within group variance. Then I have the mean IQ of all these 3 groups. Like I have the mean IQ of a community medicine people, I have mean IQ of a surgery participant, and I have mean IQ of the other group. So if I take, and then what will be the overall mean IQ? So it will be the all individual divided by the number of individual, right? That's how we calculate the mean. So if you have got overall mean, and if you deduct the group mean from the overall mean, square it and divide it by the number of groups minus 1, that is your between group variance. Like if I have got, like, let's say if the IQ is 100 of the community medicine, 110 of the surgery, and maybe 120 of others. So what will be the overall mean? 110 plus 100 plus 120. So there will be some mean, like maybe let's say 110. And if I deduct the 110 from the group mean, so there will be some value. You square it, divide it by the number of group minus 1. In this case, the number of groups are 3. So I will do like 3 minus 1, that is 2. So this is your between group variance. In this case, you can see that there are 3 rays, black, white, others. These are the individual. Sorry. So these are the individual BMI of each group. It is not the BMI of one person. So it is the BMI of each group, like overall mean BMI of black race, 500 people. Again, the mean BMI of white people, and then others. And then, so overall mean like 20, 22, and 24. It came out to be 23. So what I did, like 23 minus 20, that is 3. 23 minus 22, that is 1. 23 minus 24, that is minus 1. I have just did the square. So 9, this is 1 and 1. Then I have added it. So this is known as the sum of square. Remember, sum of squares. So this is sum of squares. And then you divide it by the number of groups. So number of groups are 3 here minus 1. So this will be your between group variance. So Priyanka, did you understand this? This slide. Okay. Then shall I move ahead? Because, okay. So this is the between group. Wherever you need to understand the between group variance, you have to take the mean of the group and just deduct it from the overall mean, square it, divide it by the number of groups minus 1. That's why in ANOVA you have got 2 degrees of freedom. You will see later. In the result, like in the other places, you will see that there is a 1 degree of freedom because there are 2 groups. But here you will have got 2 degrees of freedom. That we'll see. So now, if the group mean values are far away from the overall mean value, then your between group variance will be high and vice versa. So your F statistics is the ratio of the between group variance and within group variance. And under null hypothesis, this value is 1. So coming to the graph, remember, if you take the individual graph, like you have answered in the previous question, the wide the graph is, more the variabilities. That is about a single graph. But if you are taking more than one graph, then if the distance between the two graphs is large, then we say that the variance is high. If there is an overlap, then we say that the difference is less. Like in this case. So can anyone explain this for me? Anju is writing between two peaks. Yeah, actually, yes, between two peaks. Even if you can take any point. If not, generally you take the distance, like this point and this point. Maybe if you can take distance, whatever initial point you are taking, like you can take this distance also. So initial distance, these distances also can be taken, not necessarily between peak. Like starting and starting of this. Okay. High between all group. So the distance between the first graph, any point which you take on the first graph, corresponding point you have to take on the second, and corresponding point you have to take on the third. So it is not necessary that you take the peak. Peak we have just shown you for example. You can take any point in this graph. You can take this also, like this and this. If you take the yellow graph and this brown graph. So I have taken this point. So this point and this point. So high within and low between. So in this case, Anju, if I say the overlap is not that much. So it is, that's why it is both high. Maybe it's drawn from hand actually. It's not a computerized graph. So we have drawn it by hand. So maybe that's why you may have some difficulty in interpretation. But if you see the second one, you will see that there is no overlap between any of the graph. So that's why we say that there is a high. In first case, actually, there should not be any overlap because there is a slight overlap here. That's why maybe you guys are confused. This one, right? So this should not have been there. Ideally, we will get it corrected. Thank you. So ideally, the graph should be like this, where there should be very wide individual graph. So that would have been the best one. So yes, you are right, Anju, that there should not be any overlap. So second, this one, you can see that this is a high between and low within group variance. Is the second graph seems okay? This one?
Madam, can I say something?
Yeah, please.
Actually, in real life, there will be some outliers in almost any cases. So there will be overlaps like that. In actual real life sample, we hardly get a very nice symmetry.
Very true. But just for understanding, I got your point. In real situation, you will not get something like this. But just to make you understand that the distance between the two, if the distance between the two curve is high, and if the individual curve is narrow, then the breadth of the individual curve tells you regarding the within group variance, and the distance between the two curve tells you regarding the between group variance. You are right. That's why I told that these are, we have drawn it, like it is not something as an output and we have just shown you. So this is just a pictorial representation of the within group and the between group variance. So Shirley, could you understand the graphical presentation? Anju is writing yes. Shirley, yes. I hope. So now let's again recap the concept of variance. So this you can see again the same thing. This case you can see that there are three graphs which are highly overlapping. And the three means they are also very close to each other, like 9, 10, and 11. So we say that there is a low variability between group because these group means are very highly overlap, and there is a variability within group is same. Why we are calling it same? Because if you measure the breadth, it is almost same in all the three groups. So variability within the group is same. In the second graph, if you focus on this graph, so you will see that the group means are farther, like 6, 10, and 14. So 3 means are farther, and then there is a high variability between group because these overlap is lesser than this. If you compare from the first one, then the overlap is less in this. So there is a high variability between group, and the within group variability is same because of the shape and size, like spread is same. Okay. So if there is a because what we did how we calculate the ANOVA. Yes, anyone please type in the chat box how we calculate ANOVA. Value of F value. Yes, Shirley, Vikram, yes, you write, please. What is F value? What is a numerator? First type that. Ratio of both variance, true. But in numerator, what we take? Which variance? Yes, it is between. So that's why you see here, it is written here. For the same type of graph, if the between group variance is less, then F value is low. If the between group variance is high, then the F value is high. So yes, true. So now have you understood what gives rise to a high F value or a low F value? Have you understood this? So if the within group variance is high, then your F statistics is going to be high. And if the F statistics is high, definitely we'll see the value of ANOVA will be significant. Okay. So now there is, again, we have done this concept before also, that is the homogeneity of variance. So the homogeneity of variance, how do we test for the homogeneity of variance? For independent sample t-test, we have seen that we did it through Levine's test of equality of, yes, Priya, right, rightly said. Levine's test of homogeneity of variance. So variances in population from where the samples have been selected, it should be equal. So we test it through the Levine's test for equality of variance, and it tests whether the sample came from the population with the same variances. So it produces two types of independent F statistics. The first is of equal variances assumed. This is same in SPSS and Jamovi. That's why by mistake it is SPSS written. We are sorry for that. Every time I say that and I forgot to change this. Then we use standard F statistics, degree of freedom, p-value, and Tukey's post hoc test. If there is a equal variances not assumed, then we do take the value of Welsh ANOVA, its degree of freedom, p-value, and in that case, we take Games-Howell post hoc test. Okay. So now there's a concept of post hoc. What is this post hoc? We'll see. But till that time, just remember there is something known as the Tukey's post hoc and the Games-Howell post hoc. So let's understand the concept of post hoc. So post hoc is basically if you want to compare the difference between the groups. So if you have got 3 groups, there can be difference between 1 and 2, 2 and 3, and 1 and 3. So like if you want to understand this concept of post hoc, you can just see this example. So 3 kids, they have planned to break their money bank. So you can see there are 3 money bank, and the question is whose money bank has got more money. So you have set a rule that if the difference in amount is more than 500, then it will be considered as significant difference. And you assume that all money bank have got equal amount. So that is your null hypothesis. So now consider the first case. Situation 1. So the first money bank has got 150, second has got 190, third 250. What is your interpretation? Is the difference between any two of these is significant or not? Not significant. Okay. Now, yes, between 1 and 3. True. What about 2 and 3? What about 2 and 3? No. Because why it is no? Why it is no? Vikram, why it is no? 400. Less than 500. True. Now, now please write what is your interpretation, in which group it is significant. All. So 1 and 2, 1 and 3. But what about 2 and 3? So can we say all groups? What about 2 and 3? No. So it's not all group. 1 and 2 and 1 and 3. But still difference between 2 and 3 is not significant. Now you say. Now Kavita and all other people who were saying all, they are right. Anju is writing all. Shruti, Deep, Vikram, Priyanka, Koteshwara. So now Kavita, okay. So now you got it that the difference in all the groups, it is more than 500. And then in this case, we can say that the post hoc group comparison is significant. So this group-wise comparison, which you just did now, this is known as the post hoc comparison. And there are 2 types of post hoc. One is your Tukey's post hoc, Tukey's. And the second is the Games-Howell. Even if you don't remember the names, no problem. If you open the JAMOV, it will have those names. So no need to think that, these names are complicated and you will forget. The moment you will see those options in JAMOV, it will be recalled. So remember that in Way ANOVA, we are comparing the means of more than 2 groups. That's why if there are 3 groups, the F statistics will be calculated using 3 pairs, AB, BC, and AC. Similarly, if there are 4 groups, it will calculate using those groups. So you will get a F. So in the post hoc, there's one rule that you get a significant F value, then only you will see the post hoc. If your F value or the ANOVA value is not significant, then there is no need to see for the post hoc. Why? Because then there won't be any difference in any of the pair. Otherwise, if there is a significant F value, that means at least one group is showing a significant difference. So if you get a significant difference, then only you should look for pairs which is responsible for this value. It may be only one pair, like we have seen in the money bank example. It can be a comparison of only 1 or 2 or 2 or 3, or it may be all pairs. So like maybe if you want to study any difference in mean SBP and mean cholesterol various across various BMI category, then also you can apply that. So let's see what is the exercise. So for demo, I will, right now we have shown you with the example of SpO2, but again, I will demonstrate it with other values also. So the first question is, before you apply ANOVA, you need to check for the assumptions. And like for independent t-test, we did the assumption checking using the exploration menu. Similar thing you will do here. In fact, we assume that in the beginning, you have checked all your variables regarding its normality and its status of outlier. So I have to check the distribution of following parameters across the comorbidities categories. That is the SpO2, SBP, BMI, CRP, cortisol. So I'll go to this. This is the ANOVA. I will delete all this. So this is the data set. So how to come to this option of ANOVA? So till now we have done this exploration where you know how to do the descriptive. We did t-test where you have learned regarding independent sample t-test, Mann-Whitney U-test, paired sample t-test, Wilcoxon sign rank, and one sample t-test, and it's non-parametric, that is the Wilcoxon test. Then you have done this frequencies where you have learned regarding the chi-square test of association, chi-square test of two proportion, and then you saw the odds ratio and relative risk. And then there is an option of ANOVA. So if you click this ANOVA, and you can see the icon also. To test, it is showing two groups. Whereas in ANOVA, it is showing, can you see, three groups. So you click this, you have got many options here. You have got non-parametric as well as parametric. So right now we'll see one-way ANOVA, but its non-parametric part is not there in the same window. So it's non-parametric of one-way ANOVA is the Kruskal-Wallis, which is the, because in independent sample and paired, you must have seen that it is there in the same window. But here, it is not in the same window. It is different. So I will click on this one-way ANOVA. So before I click on one-way ANOVA, I have to check the normality across three groups. So for that, what will I do? I'll go to the exploration, descriptive. So all these variables, BMI, SBP, maybe SpO2, cholesterol, vitamin D1, these values probably I will check it by the three groups. The three groups in my cases are the comorbidities, where I have divided this comorbidity into the no comorbidity, 1 to 2 comorbidity, and more than 2 comorbidity. So this I have done. In statistics, I will undo this, uncheck that because I don't want this. So I'll only go with this plot. In plot, I will click on QQ plot and box plot. So it takes some time because there are many variables. That's why it is buffering. Now, how to interpret this box plot? Yes, anyone, you may type in the chat box. What will you write in your interpretation if you see such type of box plot? Yes, please. I'm waiting for your answers. So let's see. I will just ask with the first one. What is your interpretation with this box plot? So median is almost in between 25th and 75th, minimal outlier. So yes, in comorbidity, there are 2 outliers. In no morbidity, sorry. What about this? So 2 outlier again in the 1 to 2. And then in the third group, no outlier. So this will be your interpretation after the visual inspection of the box plot. If I go down, what is your interpretation on the QQ plot? So first, let's see this one. What, according to you, what is the normal or not normal? Almost normal. Okay. Can be normally distributed. So we can take it as a normally distributed. Okay. So this was regarding the which variable? So we'll have to see BMI. So this was BMI. Similarly, you can see the others, like this was systolic blood pressure. So 1 outlier in 1 to 2, and then there was 1 outlier here. And you know now how to, if you don't want to take this, we should use the option of either you can delete the value, have an alternate sheet, or you can use the filter. Yes, Anjana, very true. You can use the option of filter. And there's a beautiful option of filter in Jamovi where you can switch on or switch off the filter depending on your need, which is not there in SPSS. You again need to remove filter in SPSS, if those of you who work in SPSS. Okay, so I will again repeat what these graph, Soma. What do you want me to repeat, Soma? Can you please type here? The same, this graph, plotting of these graph, box plot and QQ plot? I'm waiting, I think. Okay, I am assuming that you are asking from first to entering data. I did not get it. Entering data means you want to like applying filter.
No, madam. Actually, the thing is, from the first you entered all names and other data, madam.
Okay, please here in the window.
From the BMI and other things, from the back one.
Okay, so I'll again remove everything. This, is it okay now? I have removed everything back to the previous where nothing is visible, right?
Okay.
So do you want me to start from this point?
Yes, ma'am.
Okay, thank you. So, okay, so what I'm doing now. Yes, Anjana, what am I doing this descriptive? Why I'm doing this descriptive? Whether I have to apply, whereas I have to apply the ANOVA. Why I'm going to this descriptive window? Yes, Kavita is right. We are doing the assumption check. Assumption check, yes. Because see, in Jamovi, check normality, true. The 2 assumptions, nearly normal distribution and should not have significant outlier. Yes, among groups, Taisin is very right. Because overall normality, if you see we will see in the one-way ANOVA, like you have seen in the independent sample t-test, it tells you the overall normality. But ideally, it should be checked across the groups. That's why I'm using this option of exploration. So I'm using this like if there are 3 groups and if you want to see what is the distribution of your dependent variable, which is continuous. So in this case, maybe I have taken few groups just for demonstration. And then I will split it across the. So if you see the BMI overall, it is how many numbers are there or outlier. If I have not put across the split, so there are 6. Yes. And if I will put this transform, then this whole 6 will be distributed actually in all the 3 groups. Maybe it is less now. If we have like spread it, number has reduced from. So it is, no, but skewness you don't check in the box plot. Box plot is only for the outlier, this thing. And which median shifting you are seeing, that is only the Q1 and Q3 positions. And by the positions of Q1 and Q3, you cannot say that whether the data is not normal or normal. You remember, you just recall your session on normality. Did I mention box plot anywhere in the normality? Hriday? Yes. So box plot is not for normality. Box plot is always for outlier. Normality, I will again revise. You have got objective criteria and a subjective criteria. Subjective criteria is like histogram, density plot, and then QQ plot. Objective criteria is the Shapiro-Wilk statistics, and then there is a statistics like kurtosis and skewness also. Okay, but box plot is only for the outlier. So this was this thing. And this difference, what you are seeing now, that is only due to the positions of the Q1 and Q3. Okay, the quartile are not equi-spaced. That's why maybe you are seeing that the median is shifted up and maybe down here. So this is again, this is one distribution. You can see one outlier here in the 1 to 2, one in again here. This is again approximately normally distributed, we can say. So this variable is your SBP. You can see the DBP. Then you can see the SPO2. SPO2, you can see there are 3 outlier in the total, this 1 to 2 morbidity. And here in more than this, again 3. You can come down and see these graphs too. So this is how you check for the assumption. If median merges with 25th or 75th, it gives a hint that skewness may be there. How come median will merge with 25th or 75th? There will be some value of Q1. You arrange your data, and then that means you want to say that same value is there. 25th and no, I don't think so, Kaushik. This is the case. We may consider these things, but it may give some indirect hint. But why, if you have got the direct this thing values and you have got any subjective and objective way, then generally we don't see. Yes, definitely, if the yes, it may give, but again, median is 5th percentile, 50th. Yes, true. I'll have to see this. I'll have to check this, and then only I can. Yes, it can be an indirect hint. Can be. Let me check it with one data set, and then maybe we will get back to you with this particular thing, like when, in what cases it merges, and then if it is merges, what is the picture in the QQ plot, probably, or maybe in the histogram. So this is your, so this we have checked for the assumptions. So now once you have checked for the assumption, these assumptions are satisfied, then the other assumption, that is the Lemine's test of equality of variance, that you get when you apply the ANOVA. So I'll click this one-way ANOVA. So let's see. I'm sorry for in between interruptions. So this I have pasted all the graphs here because I had to check that. And then is the question. So I have to check the mean SpO2 level of patients across the comorbidity category. So mean SpO2. This is the SpO2. I will move to this dependent variable because you can see here there is a sign. Oh, okay. Subjective and objective. So subjective is when you have to see the graph, like QQ plot. And Pallavi has rightly written, when the sample size is more than 50, then you go for the subjective plot. When it is less than 50, then you go for the objective test, that is Shapiro-Wilk. Because with the higher sample size, Shapiro-Wilk will always be significant. And then you will end up saying that it is not normally distributed. Because remember what we talked. If the p-value of Shapiro-Wilk is less than 0.05, that means your data is not normally distributed. So for a larger sample size, this p-value is always less than 0.01. So if you use objective criteria, you will always label that the data is not normal. Okay. That's why with more than 50, you do the QQ plot. And QQ plot is subjective way. Subjective, why subjective? Because there is no value. Objective, when do we say that it is objective? Like we have got some objective criteria of pass fail. Na? If the marks is less than 50%, you will be failed. Okay. This is one objective criteria. So Shapiro-Wilk, when you say that the p-value is more than 0.05, then it is normal. That is objective criteria because that value is visible. But when you have to say, like in this case, someone might say, no, I will not take this as a normal distribution. Okay. Someone might say, okay, this is not normal for me because these values are lying here. So this is subjective because it may differ from one person to another. Okay. Is it okay? The subjective, let me see. Siva, okay. So this, I have entered this SpO2 in the dependent variable box and then the grouping categories, which is the comorbidities in this box. So now you will see that by default, this is checked. Equal variance is not assumed because they say that the equal variances, most of the time you will find that this is not an easy assumption to met. Most of the time it will be violated. In that case, you will have to go with the Welch ANOVA values. So value of ANOVA is there. So what is the value of ANOVA? It is 0.197. What is the F statistics? It is 1.65. And you will see there are 2 degrees of freedom. So there is a 2 because there are 3 groups. And this is again another degree of freedom. This is for the individuals. We'll see that. So this is not significant. So if this is not significant, again, you can check. See, normality and QQ plot, you can check here also. But here it will give you overall. It will not give you split. And if you think that this is not normally distributed, then what you should do? You should go for the Kruskal-Wallis. Because in the same window, you will not see Kruskal-Wallis. And if this is not significant, then will you go for the post hoc test? Right? Yes or no? No. Yes. So I have not checked for homogeneity, but you can check Levine's test. What this value says? Whether the variance, equal variance is assumed or not assumed. All of you, please write. Assumed. Yes, true. So in that case, where should I click here? Is it okay, the option which I have clicked here? Will I report Welch or will I report Fisher? Yes. So I'll check this, uncheck this. And then you can see, again, it is not significant. So this is how you do it. So there is no need now, but I will go with some other variable, which is normally distributed. So maybe I can take the BMI score. This is again not significant. So which variable I'll have to see? Maybe vitamin D. This is also not significant. So these variable in my case, maybe if I change this to any other category, maybe if I take this disease severity. Then also it is not. So that's okay. In my case, it is not significant. But again, even if it is not significant, just as a this thing, what should I do as a post hoc? So I'll go with this SpO2, the initial example. And then I can go with this example of this total number of comorbidities. This, we have seen that. And in the post hoc, so if the equal variances are assumed, which should I take? Games, Hobble, or Tukey's. It is written here. So I said now you don't need to remember. Since you have, when you will click this Fisher, you have to click this Tukey's. If you click Welsh, you have to click Games, Hobble. Okay. Equal variances assumed and not assumed. And then if you do so, you will get a box like this. Here, since overall ANOVA was not significant, so you will not get anything significance here. It tells you the difference, mean difference between like how to read this table. You will go like this. So this value tells you the difference between a group which is okay. I will tell that, Koteshwar, I will tell that missing values. So you have to compare this 1 to 2 and then this no comorbidity. So how do you read this? You go like this on row and on column. So this is the minus 1.07 means this is the difference of SpO2 level, mean SpO2 level between the no comorbidity group and comorbidity group of 1 to 2, which is not significant. Similarly, how will you read this? Yes, anyone who can unmute and answer this? How will you read this? Maybe Vikram, I can see your name in the last.
Ma'am, 1 to 2 versus more than 2. So the
True.
mean difference is minus 0.173 with non-significant p-value.
True. So very right. You have to see like whether it is falling, where it is falling. So you will see the column and you will see the row. Because the others with the same thing, it gives a dash. Okay. So this is how you will about the post hoc comparison. Now, Dr. Chintamala has asked one question. So anyone from the group who can answer this missing values. Maybe I'll have to demonstrate it, but just for knowledge, I'll tell you this. Exclude case analysis by analysis. This will be ticked above by default. That means, like, let's say, and the second is a list wise. So coming to the data, okay. So in a data, you are doing a post hoc and or anything like BMI, if one value is missing here, okay. If one value is missing, it will not delete the entire row. It will only, if you want to do the analysis of BMI, it will not take this value. But if you are doing the analysis of systolic blood pressure, it will take this 110. But if you click that option, the other one, it will delete the entire third case. It will not take any values in the third case. Remember, so this was the ANOVA. So if I click this, the other, exclude case list-wise, it will not take any value in that row, even if there is a one value missing. If you click this exclude case analysis by analysis, that means it will only count that particular missing value where that particular value is not there. Otherwise, for rest of the values, it will take the other values. Did you get it, Dr. Chinta? Yes, so full row will be deleted in list-wise. If you click this option, you are going to lose one full data because it will not take any data of that particular row, even if that one value is missing. So that's why we never recommend to do this, because then you will be losing on the other data, right? So that's why it's always better to click this option of exclude case analysis by analysis. Okay. So if it is done, then we'll go to its interpretation. So this is how you will write the, like I have entered the mean and standard deviation. And then I have written the Levine's value with 2 degrees of freedom and its p-value. The one-way ANOVA, the degree of value and its p-value. So I've written here note, ideally pairwise comparison we don't do if the ANOVA is not significant. But only for demonstration, I have written like if it is significant, how to make the table. So I have just copy pasted the same table here, which you have seen in the Jamovi. And then this is the write-up. So one of you need to read this write-up. Who is going to? Dr. Chintamala, since your name is last, can you read this? Is it visible or should I increase the font? I mean the...
Yes, ma'am, no problem.
Okay.
Interpretation. A one-way ANOVA was conducted to determine if the SpO2 was different for various category of comorbidity. Participants are classified into 3 groups. Group 1, N is equal to 124. Group 1 is 124. Group 2 is 35. And group 2 is 21. There was no outliers in no comorbidity category.
Right here, it should be group 3. My bad. I'm sorry.
Group 3, yes, ma'am. Group 3 is 21, and there was no outliers in no outliers in no comorbidity category, and 3 outliers in 1 to 2 morbidity, and there are more than 3 morbidity category assessed by the box plot. The SpO2 was approximately normally distributed for each group as assessed by the visual inspection of QQ plot. There was homogeneity of variances, that is a p-value of 0.331 as assessed by the Levine's test of homogeneity of variance. The data is presented as mean plus or minus standard deviation. SpO2 levels were not statistically significantly different between different categories of comorbidities. F value is here 1.65 at a degree of freedom to 2177, and p value is 0.197. SpO2 increased from the no morbidity, that is 94.9 plus or minus standard deviation 4.23 to 1 to 2 morbidity, that is 96 plus or minus 4.29. And to more than 2 morbidity category, it is 96.2 plus or minus 3.78. In that order, QK post hoc analysis revealed that the increase from the no morbidity to 1 to 2 morbidity was statistically significant. That is p-value.
Okay. Yeah, I'm sorry, it was not significant.
It was not.
Yeah. So thank you so much, Dr. Chintamala. Actually, I had written here the post hoc also, But generally, in this case, when the overall ANOVA is not significant, you are not going to do post hoc. So maybe with some other variable, I think the assignment which has been given to you, there the ANOVA is significant. So you can see the post hoc.
Okay,
So
ma'am.
Vikram is, thank you. Vikram is writing why DF is not absolute value. Okay. When you will take the Welsh one, then it is not absolute. It does some correction. How it is done, that even I don't know. But
No,
it is
ma'am, I think it's 2,177. No, not 2.177 degree of freedom. It's
no,
2
no,
degree
here
of
it is.
freedom.
No, that's okay. I think Vikram is writing in the comment.
Yes, ma'am. Actually,
Oh,
he's asking why not 2 or 3 absolute. Why in decimal? He is
okay, no,
meaning that.
it is comma. I'm so sorry. 2, 177. Actually, with this Welsh, the degree of freedom is always there. Like, okay, so you are saying that this one, write up. Okay, I got you wrong. Let me check.
Yes, in the write-up only, ma'am. It is.
No, it is comma. It's a typo
Yes.
error, maybe, or it's a comma.
Okay.
The style of font is like that. It is appearing. Let me see. Is it full stop? No, it is comma. It's comma. Okay. So this is with regard to the one-way ANOVA. So I'll once again, they summarize their steps. So I'll move these back to this window, uncheck all this. Then now if you have to do any, like any BMI, if I am checking, so you will move this dependent variable here. Grouping variable could be any variable which has got more than 2 category. So might be this comorbidity. And then in that descriptive, I forgot to click that descriptive plot. You will always click this descriptive, then only you will have this mean and standard deviation, which you saw in the table. And then you will, initially you will do the assumption check. So you will see the, this is 0.07. So it is more than 0.05. That means equal variances assumed. So I'll report this Fisher. And then normality across the group I have checked. So that's why I'm not clicking the QQ plot here. But for overall, you can see. And then post hoc, because overall ANOVA, if you see, it is not significant. So I don't need to apply this post hoc because overall ANOVA is 0.45. So this is how you do the ANOVA. In your exercise, I guess it is significant. Again, the difference is again, I have told you how to interpret it and how to write it. You will get these sheets as a reference material of these write-up. So you can like use it in a tailor-made fashion wherever you want to put these assumptions or these write-up. Okay. So if it is okay, anything which you want me to repeat before we go to the breakout room?
Madam, you can use hemoglobin 1 with socioeconomic status of 3 groups.
Okay. Let's
So
do
it is significant, madam.
Oh, good. So
So we can understand post hoc with that.
Okay, thank you. I'll go with this SES. So yes, you are right. You can see here that overall ANOVA is significant. What is report significance? What Priya is writing?
Ma'am, actually, what is report significance below assumption check? There is a...
Okay. This one.
Yeah, yes, ma'am.
This is for the post hoc. We'll just see. Because there was no post hoc was not significant. That's why I did not click it. Because even if you click it, it will not come. Overall ANOVA is significant in this case. Homogeneity, if you see, it is met. So equal variances will be assumed. Normality you can see. And then in this case, now you will apply for this post hoc. You will click this mean difference. You will report significance. It will give you a star value. So report significant means if you click this flag significant comparison, report significance, that means this will tell you the p-value. Report significance means that whether the difference is significant or not. That we mean by this. Mean difference is by this. Mean difference, if you click this mean difference, it will show you this value. Okay, this mean difference. If you click this report significance, that means it will give you p-value with each difference. And if you click this flag significant comparison, it will give you this star here with 1, 2, or 3 star. Okay, so Lokesh is writing our data occur by random chance. What do you mean by that, Lokesh? You mean to say that this comparison of hemoglobin and socioeconomic status? Maybe you can clarify a little bit more. I did not get your question. So Priya, is it clear now?
Yes, ma'am. It's clear.
So Priyanka is asking, which is rep in row and column? So which row and column? Let me see. Okay, represented. So you're asking about this post hoc, Priyanka? Okay. So this tells you regarding the group. Actually, this is the same in both the group, in both the row and column. It is the same difference, but this gives you the comparison. So like just now we discussed, like if you take this value, so this is the difference, mean difference between a low socioeconomic status and a medium socioeconomic status, hemoglobin. And here it is dash. Why? Because there won't be any comparison between the same group. This low group and this low socioeconomic. Both cannot have any comparison. That's why at places when both the groups are same, like you can see medium and medium, it is represented by a dash. Similarly, high and high, this though it is dash. But if you see this is the high versus low socioeconomic status. This is medium versus high socioeconomic status. So this, both the row and column, that represents the same group. But where they meet, you have to see in which group it is telling the difference between which two groups. That's the way we write. In SPSS, those of you who do the SPSS, you will see that all these are populated. It doesn't represent by dash. So there you need to see it actually. But in Jamovi, it gives only one value and the other it doesn't give. It just represents it by dash. Okay, Priyanka, did you get it? So
Madam,
any other?
Can I ask you one question, ma'am?
Please.
Madam, in frequencies, actually, when you open the frequencies, it will show two lower columns. Just open the frequencies, madam. And in that independent samples, you go to the independent samples. And here there are two layers, counts and layers. What is that, ma'am?
Okay. So count is like you already have a 2 by 2 table. Like here you have got individual data. But when you have got the count, like many times, remember, if you got 2 by 2 table, then you have got 10, 20, 30, and 40. In that case, you use this. But generally these days, we have got individual data.
Okay, ma'am.
It's the rows and column actually. We have we have got raw data, but many times what happens that you get some student thesis and this we use maybe to verify. When you get a thesis we evaluate thesis. Do we? So we get many times the PG student thesis In that case, they make a 2 by 2 table or a n by n table. So in that case, you can use these options. But for those options, we go for the manual. There are many manual chi-square or the other frequency checkers also, where you don't have the data actually. That data sheet is not there with you.
Okay. And what about the layers then?
Okay, so layers, actually that time nobody asked, so I also did not tell. So I'll just tell you now, you can have one more layering. Like if you take maybe the smokers. So smoker as a, maybe I just want to see social, because right now I just did with the BMI. So socioeconomics, in socioeconomic status, how many are smokers depending on that? So socioeconomic is a independent. And since smoker is a dependent, I'll put that in column. But I want to see, so this way, you will have a 2 by 2 table. Let's wait. And then maybe I can go with the cells and I can click on the row percentages. But I want to see what, is it same in the male and female? Like here what you see, that maybe in the high socioeconomic status, there are less smokers. And in low socioeconomic status, there are more smokers. Can you see that?
Okay.
43% and 19%. But I want that what is happening to male and female. Is it same in male and female? Then I may put a layer here.
Okay.
So now it will take first layer as a gender. In gender, it will give you low, medium, and high, like male and female. So now you see, in female, who are of low socioeconomic status, there are 32% women who are smoker.
Okay.
In male, who are of low socioeconomic status, there are 47% are smokers. So can I say that among female low socioeconomic status and male and female, the male smokers are higher than the female.
Okay.
So you can have layering. You can have one more layering if you wish. But that will be very complicated table. Then it will have a diabetes, yes, no. Then gender, then socioeconomic status, and then yes, no. Can you see?
Okay.
Okay.
Thank you, ma'am. Thank you.
Any other question before we go to the breakout room? Okay, if not, Akanksha, can you please open the breakout room?